Hello everyone, this is Hemalata, Department of Agriculture Engineering, Assistant Professor. Today we are going to see about measurement of water yield from watershed in the subject watershed planning and management. Water yield is defined as the amount of fresh water derived from unregulated flow. Measurement for a given geographic area over a defined period of time. Understanding water yield is crucial for managing the watershed and for the sustainable water resources. The freshwater flow is generated from the combination of base flow, interflow, and overland flow originating from groundwater. The flow rate consists of the interception, infiltration, evapotranspiration. The state of water storage from lakes, aquifers, snowpack, and soil moisture. By understanding the water yield, we can better manage the water resources and for the sustainable management. Importance of the watershed. Estimation of yield is important for the allocation of the water to the various sectors like irrigation, industry, and urban areas. It is important for several reasons. It helps to understand the availability of water resources in a particular area and supply for the various purposes like agriculture, domestic, and industrial needs. The monitoring water it helps in assessing the health of the ecosystem and maintaining the water bodies. Quantifying water yield helps in assessing the water availability for various resources such as irrigation, drinking water, and hydropower generation. Factors affecting water yield, that is precipitation, temperature, watershed size, location, and primary water resources. There are two methods of the measurement of the water yield, that is direct method and indirect method. The water yield of a watershed may either be measured directly on a single outlet on the mainstream or can be calculated through empirical equations based on important physical properties of a particular watershed. Using the directly measured runoff values, it is the best way since it takes a long time and investment. The empirical method is preferred in application. In case of direct measurement method, first one is direct measurement method. It can be roughly calculated by dividing the main annual volume of stream flow in meter cube per year that is produced in a nested watershed and the area of a nested watershed using the approach. For example, the watershed associated with the station where one has a nested area of 15 kilometer square and gross area of 15 kilometer square, they are the same as no further upstream watershed exists. The watershed associated with station 2 has a nested area of 10 kilometer square and gross area of 25 kilometer square. The water yield can also be expressed in millimeter. Depth of water is spread uniformly over the watershed area, as both precipitation and evaporation are typically expressed in mm. For example, a watershed with 1000 annual precipitation and an annual 40 percentage, that is 400 water loss due to evaporation would have a water yield of 600 per year. This direct measurement helps in understanding the actual amount of water available in a watershed, which is crucial for water resource management and planning. Advantage of direct method: it accurate measurements of water flow in streams or rivers, real time data for monitoring changes in water flow, identification of specific areas contributing to water yield, essential for effective water resource management and planning. Disadvantages includes can be costly to implement and maintain, They require specialized equipment and expertise for accurate data collection. It may not be feasible to install stream gauges or flow meters in all areas of interest. Direct measurements may be affected by factors such as debris, sedimentation, or changes in the channel morphology. They may not capture the full spatial variability of water flow within a watershed. These were the direct measurement methods. And second one is the water budget approach. It is water yield from watershed with deep soils and high infiltration capacities can be estimated with a water budget approach. Soil moisture storage characteristics governing the relationship between the precipitation and water yield. Monthly values of precipitation and potential evapotranspiration are the only data required in this method. Soil moisture storage characteristic can be estimated from soil texture properties and the effective rooting depth of vegetation. The difference in precipitation is considered roughly as the water yield from the watershed. Next class we will see about the indirect method. Thank you.